Now let's look at a new model that we haven't seen before, the patterns model. I've got some directions kind of written out here, just like some key points to remember. And the main one is you got to make sure to write down what the pattern is. So when you go to show work for this, that you're going to turn into me, you're going to want to make sure to communicate what the pattern is. I'm not there with you, so you can't verbally communicate it to me. So the only way you can communicate it is by writing it down. So you are going to have to show all of these steps for these problems. So what a pattern model does is it wants to take a problem that we might not know and turn it into a problem that we do know. So I'm going to start with a slightly different problem here. So 5 plus -2. So I'm going to take a negative number and I'm going to change, I can only change one, but I'm going to change this to a problem that is a little bit easier to solve. So I'm going to change it to 5 plus 2. Well, this is a problem I know. That's 7. Right? So say my students don't know how to add those negatives, I'm going to turn to a problem that they do know how to add, get their confidence up. Now I'm going to start backing that problem up. So that number that I changed, I'm going to back that all the way up until it becomes the problem that I started with. So notice the problem I started with is going to be down here at the end. Even if my students don't understand negatives, I bet they'll know that 5 plus 1 is 6 and 5 plus 0 is 5. So then I can show them, oh, the pattern is each time I'm subtracting 1. So the next number, the number I wasn't sure of, is going to be 4 and then 3. So I can really show them that this is just a subtraction problem. This is the same thing as 5 minus 2. That's the whole point of that patterns, is we can show them that it really is just subtraction. Let me put another one up here. This would be a great time for you guys to try a problem. So it would be a great time to pause and see if you can write out that patterns model. And I'm just going to remind you, you can only change one number. So you got to choose one. There's no right answer here for which one you choose. So choose one to change. So go ahead and hit pause and see if you can get this to work. And of course, we know the answer is -5. So see if you can get that. All right, coming back from pause, it doesn't matter which one you change. I usually change the one that's closest to 0, just so I don't have as much that I have to do. So I changed the -2 to a 2 here. Oh, let's say my pen stopped working. Hold on one second. When it stops working, I just have to pull up something else here. Get it to back turned on. There we go. So I changed that -2 just to a 2. And then I'm just going to back this all the way up so that I have the same problem. So -3 plus 2 is -1. -3 plus 1 is -2. -3 plus 0 is -3. So the pattern is, again, each time I'm subtracting 1. So it would be -4 and then -5. So I could show that really this right here, the plus and negative, is just a subtraction to make it look a little bit easier. So those are kind of our methods that we have for integer addition. We also have our properties. We have all of our same properties that we had before. So the commutative, the associative, the identity, and the closure are all still true for integers. They were true for our whole numbers. They're also true for integers. So like for commutative, -3 plus 5 is equal to 5 plus -3. We can change that order of the operations and we're still going to get the same answer. For the identity, just kind of spot checking some of these. Whenever we add 0, we get the same number out. The identity is true. Now we're going to add 2 new ones. Well, we're going to add inverse and then a few other ones with the rules. So the inverse, this is going to be the additive inverse. We're going to have multiplicative inverse later on in the semester. So this is just true for addition. If you take a number and then its inverse they cancel out, and they get you actually back to the identity. They get you back to 0. And we kind of talked about that way back when I was up here, and I said it was all the whole numbers plus their inverse. So the inverse of 3 is -3. So I could do it for any number. The inverse of A is -A, and that gives me 0. I also could write it this way as well, because I can flip the order of them because the commutative also works. Now our other rules are true. These don't have fancy names, but 2 negatives do end up making a positive. So a -A ends up being a positive A. And then we also can have the idea of distributing across our terms there. So we have the idea of distributing. And I also could write this as -A plus -B. I'll write up one more. So if we have positive A, that's just going to be a -A. So 2 negatives turn out to be a positive, 1 negative stays a negative there. So for this next one, we're going to take this idea of the inverse. So the inverse is when we have a negative on the outside, the idea of an inverse. Same thing up here. We've got those inverses, and apply it to some algebra steps here. So if I wanted to find the inverse of these, I would want to find the whole thing negative. So I would need to distribute that to get -x minus 5. So that would be the additive inverse of A. So B's a little bit harder. I'll freely admit B's harder. Why don't you pause the video and give B a shot, and then we'll go over it after you've given it a try. Let's see about B. I'm going to take everything that I have. I know there's lots of parentheses, but I took what was given to me and I copied it directly over inside a set of parentheses. And then I'm going to distribute the negative. And I'm going to remember that 2 negatives make a positive. So this would be 5 plus B. I'll show a little step because that's, like, it's messing up again. I don't know what's going on with it. That would be -5 plus a -negative B. So these 2 negatives make a positive, and those 2 negatives make a positive. So I end up with all positives.